I will introduce Dr. Hamdi. Dr. Hamdi Al-Hakimi is a researcher in Oxford University in the application of machine learning in medical diagnosis. He continued his master in public health from Public Health Institute, also Sudan. He then finished his MD, medical doctorate in community medicine. He works as epidemiologist in Federal Ministry of Health Science in Sudan. He established an epidemic forecast unit and built models for cholera and influenza prediction. He works as assistant professor teaching epidemiology and research methodology in Al-Baha University, Saudi Arabia. Dr. Hamdi established an office for research consultation and supervision. He did actually the second master in the epidemiology in Oxford University in Netherlands. He will talk about the network analysis and epidemic surveillance, a new approach to contact tracing. Actually, in Arabic, it will be like تحليل الشبكة والمراقبة الوبائية نهج جديد لتعقب المخالطين. هذا أعتقد ينفع الآن. It will be good in COVID-19 media. You can start, Victor. Share us your presentation.
Already shared my presentation. Is it obvious?
Go ahead.
My presentation is obvious for everyone. Okay.
Yes.
Thank you. Thank you, Dr. Mohanna. Thank you, Dr. Adel Ghaiti. I appreciate this effort to connect researchers and scholars from over the world, Yemenis and non-Yemenis, and this, we know that research and science is a teamwork. So we need to connect with each other to like exchange knowledge. I'm talking today also about social networking. So you did social networking for scientists from over the world. Thank you so much. So my topic today is to talk about social network analysis and epidemic surveillance. This presentation, most part of this presentation are 6 years old. Already presented some part of this presentation in epidemiology department, Federal Ministry of Health in Sudan. It was like a new idea to control direct transmitted diseases like influenza and meningitis. You hear my voice? It's okay?
Yes, clear. Go ahead, Doctor.
Okay. Social network analysis, don't like confuse social network with social media. We don't talk about social media at all. We talk about social networks in the society, the networks that you move in society, your family, your work, your leisure and activities, outside activities, the people that you interact with. So what is SNA, social network analysis? Well, I will do some introduction about that, of course, because it may be for many people, it's a new concept. And literature, I will talk about some interesting papers that tackle the subject of social network analysis in epidemiological problems and how to use this SNA epidemic surveillance. I did before that like a roadmap how to do that step by step in epidemic surveillance, which is still now after 6 years. It's not introduced in the Sudan or any part of the world, as I know, and I motivate and I advocate for introduction of SNA analysis in the epidemic surveillance. And also we have a great opportunity if we link the effort of epidemiologists and the effort of microbiologists, we will do a perfect social network analysis, and you will know how. So what are social networks? Social networks, recently a considerable interest is given to this concept of social network because it's most related to the spread of infections. And we know now about social distancing. And the main aim of social distancing is to interrupt social networks of people. So the infection could not transmit it easily. We know in the sociology that diversity and strength of social relation is very important for individual health. Yeah, but in case of epidemics, the socialized person, the more socialized community is more vulnerable for epidemic spread. So it's disadvantage in the term of epidemiology to be more social. This is an example of social network, just to make clear what's social network. Like this is an example of network for a teenager. And we can see that the household contact of 4 people, and he has also extended family like uncle, aunts from like 10 people or something, and he has also neighborhood contacts, and he has also school classes contacts, and everyone at random, maybe in the traveling or in leisure activities on anything else. So everyone have like similar social network for this teenager. So social network science is study how this social network is performed, or and why. So that is the difference between sociologists and epidemiologists. Sociologists are more interested in the reasons of organizing of this social network, why people organize themselves in the community in this network. But epidemiologists are more interested in the structure of social networks rather than causes of network formation. We study the structure, we get like inferences and conclusion from this structure in relation to the infection transmission. Social network have a great importance in understanding infection behavior. We'll see that. People interact with a varying number of individuals, and with some individuals more than others, and this affects transmission of infection in a fundamental way. An assumption that's common sense, that we interact with our family, with the job contacts, and with maybe event contacts that we attend more than any other people in the community. So this is like statistical concept that the chance to interact with close people, with relevant people are more than others. That conception of that builds social network. So what's the social network analysis? Social network analysis is a new statistical approach based on concept of interdependence between observation. The classical statistical approach that we know, like chi-square, like t-test, like regression, it's mainly the main assumption that the observation in your data set are independent. There is no relation between people in the data set. But the main assumption of social network analysis is that people are interconnected, which is morally realistic. We are more connected to each other. And this is a great advantage of social network analysis, because in classical analysis, we do only have in our data sheet only other patients, or another data sheet for contacts, but we cannot mix patient with contacts. That make problem in the analysis because they are defined differently. But in social network analysis, we can do analysis for patients and contacts and suspected and all social network of them in one at once. So let us see what Danon said. The study of the spread of directly transmitted infection is intimately linked to the science of networks. So what types of social network? I just here mention some types of social network. If you search literature, you can find a lot of types of social networks. But I think these the main types that if we just go through it to know what's the concept. We have like random homogeneous network. This network, if we build network of random homogeneous people, so we assume that there is no clustering. There is no clustering, and that means that every person in this network, this community, have the same chance to be contacted by other person in the same community. So there is random mixing of the people. And this assumption for this network is idealistic, is not realistic. Other type of network called lattice network. And in this network, it's the opposite of random mixing. It say that highly clustered people are moving only in clusters. I would translate it to the practice. It means that the Lattice network means that I move only within a cluster of my family and job and sport. So I don't have any other contacts, and that's not realistic because I move randomly in the transportation. I move randomly if I travel. I go to some random things. So it's also non-realistic. The realistic network is something in between, like small world networks. So small world networks, you are moving within your family networks and your job networks, and also you have some random possibilities to work to contact people random. That's more realistic. Scale-free networks also the other type that can allow in the analysis to extreme heterogeneity. What's the extreme heterogeneity? It's what we heard about super spreader of the infection. If we apply that for infection, it's super spreader of the infection. It's a person in the network that have a lot of contacts, like hundreds or something, and this type of network scale-free can adjust for this type of spreaders. So this is the types of social network, just to know that. Now it looks interesting how we can apply this concept in the epidemiology. So I will give you some papers that use social network analysis in solving epidemiological problems. Dan et al. Conducted a survey in UK, and he sent like 140,000 randomly selected households sent questionnaire. Yeah, participants were asked to note down the question of the survey was note down each face-to-face conversation within 3-meter distance during the course of the day. That was the question. And the collected data are analyzed and modeled to build a network to transmit a hypothetical infection. And what was the result? The result was early epidemic growth rates and final epidemic size. All of them are greatly affected by a structure of networks. Structure of networks is affecting the epidemic growth rate and final epidemic size. So that's important for any epidemiologist to understand. Another paper of Sarah Del Valle in the United States, also they conducted social network modeling for real data and investigation social structure, contacting behavior, how many contacts per day, how long of contact, what's the type of contacting, is it physical contacting or it is distance contacting? A lot of information that you need sometimes to build a perfect network. They concluded that structure of human contact networks play a crucial role in transmission of many infectious disease. Myers, this paper I like it because it's more for practice and it leads to change of policy by CDC because Myers built some of the first network-based models in the healthcare to evaluate, to compare two preventive strategies for walk-in pneumonia. Walk-in pneumonia is type of pneumonia that occur within closed setting, like a ward in the hospital. It's closed setting. So this type of pneumonia have a protocol. A current protocol was to isolate the patient and give antibiotic prophylaxis. But the strategy in the blue color that studied by Myers was better in control of walk-in pneumonia, and this strategy was based on the social network analysis for contacting between the doctors, the nurses, and the patients, and it was like the strategy finally was after initial diagnosis of pneumonia, reassigning of caregiver and limiting of their interaction with patients. So no antibiotic. So this CDC accept this new strategy for control of walk-in pneumonia in favor of isolation of patients, the old strategy. So this is one application of network. So also Hashimas, yeah, they quantify how transmission of influenza, which is more similar for corona in science of epidemiology, direct transmission and respiratory disease. This transmission, as found by Hashimas and their colleagues, are affected by social network. As we see there, the social network for school students in USA, and he found that the red color is for females, and the blue color is for male, and the connection between them are, as we say in this figure. And what was the finding of professionals? They found boys were more likely to transmit influenza to other boys than girls, which mimic the observed mixing among primates. What I mean that the social networking, the process of girls and boys, it's the male process to transmit infection. And he found, when he did modeling for that, he found that late closure of the schools had no significant impact on infection. So in the term of influenza, as he said, that early closure of a school have significant impact of infection based on this finding of social networking and social contact between boys and girls. Laura has built a social network also in United States. She asked the people these questions, and based on this question, she built the social network of 10,000 individuals. What the question was, what are your groups? How big are they? How often do you go to the with? And this the main question in any social network is, how many people do you interact with? This is a social network example that built by Laura. And the result, what was the result? After Laura built the social network of 10,000 people, she did a silicon experiment. She did modeling simulation, and she make in this simulation vaccination for 80% of school children. And she found that when we vaccinate 80% of school children, it gives us the same effectiveness as vaccinating 80% of entire population. That's a huge difference. We can just vaccinate school children based on these results, and that will like do the job of vaccination at whole community. So how can we use SNA in epidemiology? SNA can visualize as a network, so we can see a graph of nodes and bonds, and we can see the social network between people and their contacts, and then we can play with colors to see who's patient, who's contact, and then see how the infection transmitted. SNA can provide graphs or summary statistics like mean and median. It looks like this, but like in social network analysis, we have different names like centrality, betweenness, but it an formative rule to make us understand how the things, infection, ideas transmitted through the people in the social network. Also, we can extract an important component or subnetworks, and that may give us incredible cluster of actors. So let me explain this in the figures because it's much easier. This is the network that I did in my MD thesis. It was like social network analysis of tuberculosis patient, their household contacts. So it's a TB patient and their household contacts. If you see these graphs, this is the whole patients, and the red dots are the patient, the yellow are the it's a primary cases, it's the index cases, and the light blue is the contact. So we can see all whole patient and the whole bonds between the patients. But someone can say, what, it's not clear for me, what can I get from this whole network? But you can fragment this network to make it more explainable. I can ask, through the social network analysis, I can ask for clusters from like 20 people or 30 people, what number I want, I can ask about it. So in this case, it's 24 people clusters inside this network that I need. So the software gave me two major clusters. And when I studied these two major clusters, I found the following. The first cluster belonging for people, most of them patient, they are working in gold mining. So they are in the poor occupational conditions and no ventilation. So that's, for me, that's logical. There is a lot of transmission, cluster of transmission in this people. Other cluster is belonging for people coming from Darfur in Sudan, which was like an area of war and conflict. So for me, it's also clear why it's they make cluster like this of transmission. So you can fragment your social network and see every cluster and explain what you find based on the characteristic of people in this cluster. Also, I can make my network moving with time, the temporal direction, so I can see the first cases and then growing and emerging of infection and pandemic through whole network. Also, I can make network in spatial and geographical dimension, and then I can see how the infection transmitted from region to region, from city to city. And I have something to tell you, as most of you are microbiologists, that if we do genotyping for these people and then do social network analysis, we can know exactly that patient is infected from that patient by like gold standard, because he has the same genotype of bacteria or virus. So that will be perfect mixing between genotyping and social networking. And I can also make sub-social networks based on genotypes. So I will see every genotype, how it's transmitted, how fast it's transmitted, which is more vulnerable contacts for this genotype. This will be very interesting. We can work on the research on this if we have that. Other possibilities for social networking graphs, we're still talking about graphs that we can get from social networking. So we can also make the node size depend on some covariates, some variables of the cases. Like why I choose here is that the size of node, the person, the graph, is related to the infectious period, the period of infectiousness. So I can see from this picture, what I understand from this picture, that people with short infectious period have more connection with others who can transmit infection very fastly than others. And this I think, is correct in the case of tuberculosis, because infectious period may be months. But in the case of corona or influenza, where infectious period is very short, so maybe it's vice versa. Maybe we found the people who have a large infectious period are more active in spread of infections. Okay, that's about graph and what we can extract from graph. And this is just like examples of graphs. We can do a lot of things with graphs of social networking, and as the other statistical technique, a lot of techniques we can use it. But I give you just an example of that. What about summary statistics, the numbers that we can extract through social networking analysis? The most important one is centrality. It's called centrality degree. It's easily the mean number of connection for each actor. It means in epidemiology, how or the average number of contacts for every patient. How many every patient have contacts? Maybe some patients have 6 contacts, or 20 contacts, and some patients are very popular or something and have 10,000 contacts. So it reflects the number of patient contact for which infection could be transmitted, and this, what we call super spreader for infection, or have large number of contacts. So this will be reflected in the centrality degree. Another summary statistic for social network analysis is density. It means that percentage of connection between all actors in relation to maximum possible connection in the networks. What I should do with this? It helps to compare networks. It helps to compare networks. As is in my research, I compared male tuberculosis density of network to that of females. I found that the network of male are twice dense than the network of females, and that may give me some hints that transmission within males will be more active. Also, summary statistics, another one is betweenness, and this is important for epidemiologists because it reflects how important this patient, we call it in social network, we call it actor. In epidemiology, we call that patient. So how important this patient is the transmission of infection between different parts of the networks. So what's the strategic position of this patient in the network? Some persons have strategic position in the network, and some persons are in the periphery. So they have no strategic connection with others. So it means how is the infection delivered and transmitted, and it's important. If it is high, that means it's okay, that's good, because a lot of people. And we have also reached the number of actors that separated one from another, and I give that, so every epidemiologist can think based on his data and the case. Is it important to know how many number of actors separated one from another, separated one patient from another patient? So, how can we use social network analysis in epidemiology department, in epidemic surveillance, when we do surveillance? I think this is my proposal, is my suggestion to use social network analysis in epidemiology surveillance. This is the first time I think that someone did that. So I will talk about it in steps. So I think social network analysis, it will help for priority of patient for treatment intervention. It will help for priority for vaccination or something. We can apply social network analysis especially in directly transmitted diseases like sexual transmitted diseases, influenza and tuberculosis, meningitis, measles, influenza, and now we can add corona. These are the steps that I told you. If we work in Ministry of Health, what should we do to have this? What should we do to have this social network analysis and in our practice? So at the first, we should do setting objectives for outbreak investigation. When we do outbreak investigation, we should have a clear objectives that we should collect the data of patients and their contacts, or what we call now the contact tracing. We should motivate and advocate for contact tracing, so we have this social network data already in hand. And we should prepare outbreak investigation forms also, templates and guidelines, so people understand clearly what should they do in the field. We should train also personnel working in epidemiology and laboratory for working with this data, for filling this data, for analysis of this data. And also, investigation training team should be trained how to collect this data, and we should supervise this training and this collection, and we should have also guidelines of analysis. And also, we should write the final report of outbreak investigation. When we did outbreak investigation about an epidemic or cluster of epidemic in some region, we should contain the graphs and summary statistics that enhance our understanding based on social network analysis. So people don't see just numbers or bars or pie chart only. We can see social network and how the infection emerged. We can also sending the data for epidemic forecasting units. I was a head of epidemic forecasting units, and if the people did this data and send it to me in epidemic forecasting unit, I can do what's called modeling, social network modeling, and I can predict the size of epidemic and pandemic and the mortality and the morbidity and the effect of preventive measures, effect of social distancing, effect of vaccination, who should be vaccinated, or when vaccination is effect and when vaccination is avoided. And all of these things I can predict it in advance, like 1 year or 2 years or 3 years in advance. So I can enrich the policy made for epidemic control. Epidemic modeling also, I talk about this, about prediction, and we can also modify epidemic control measures. For concluding, social network analysis could improve our understanding for epidemic dynamics. It will participate in epidemic containing in a cost-effective manner, because some people think, oh, it's social networking, it's so expensive. Not so expensive. It's just like what you do in the field. You just collect the data, but you have clear guidelines how to collect the data about people, infected people and their contacts, so that this data could be utilized in social network analysis. It will give a clear idea about the dynamics of infection transmission. And if we have genotyping for these people, for this infection, we can exactly, by evidence-based, say that this infection transmitted from this person to this person in this way. And I think this will come in the future. Thank you so much for your listening. I hope that the topic was understandable for you, and I am ready to receive any questions or comments.
Thank you, Dr. Hamdi. Thank you so much for your very nice presentation. We will be open the question and answer. Anyone have question, please raise hand, and Dr. Naif will can open the mic for you. Dr. Abdullah Mahdi.
Yes, with you.
Yeah, Dr. Abdullah, very nice to see you with us and join us.
Thank you very much. Thank you for your invitation. Thanks a lot.
Yeah, how we can use this one for COVID-19 for today?
I think Dr. Hamdi he can answer this. How we can use, network, social network to detect, for example, the movement of this COVID-19.
Yes, Dr. Hamdi, how we can use this one for COVID-19 these days?
I already used this social network modeling. It's advanced way of social network analysis in Yemen for modeling of COVID-19, the first wave in Aden and in Sana'a. And based on that social network modeling, I made recommendations that we should not stop working. We should not close shops or do complete quarantine. I said we should do smart quarantine, not complete like other, just mimic what other do. No, we should do our things. So in this recommendation was very flexible. Don't close the live for social life in Yemen. Just restrict the activities, the mass activities like weddings, like religious things. Everything have activities, have a lot of people. These things should be stopped, and this will lead to 70% reduction in the cases. So that's a huge reduction from epidemiologist view. And if someone just, I think in Yemen, people, they didn't follow any instruction for social distancing, and we got, I think, a good level of herd immunity. But if we did it in scientific way, we should close big events and keep the life going normally. That's what I did before, and the predictions was accurate in the figure, in the shape of the curve. I predicted that within 3 months, the wave of the epidemic will going down. I was a little bit
the voice.
Like 3 times before, because of the parameters that I entered to the model was based on the data and the internet data, and what I found data, there is no accurate data about Yemen. So the number of mortality was higher. The shape of curve, the end of first wave, it was in August, or in the end of the August, was really the same. So I become more convinced about the ability and the possibility, the chances that made by this type of analysis and modeling. Thank you.
Thank you so much. Is there any more question?
Yes, I have one question also for Dr. Hamdi. I think this is very interesting, topic and research for us and for all the microbiologists in the whole world, not only in Malaysia or Yemen or Holland or Netherlands. So I think in Malaysia and also in Western countries, especially in Europe, they have different programs, software, for example. This software, they collected information from different sources, from different countries, for example, like WHO, and what they have now, they have what we call it word meter to detect, for example, the movement of this what we call a strain of this COVID-19. I see the social network, which you draw it in the slides, is similar like phylogenetics, which we draw it, for example, phylogenetics, which we draw it for the similarity between different microorganisms. But now we affix it to the patient. So we can detect the patient and we can detect the strain. My question, there is any, for example, companies, the major companies, where they are using this software or they sell it this software? Thank you.
You mean that software of social network analysis?
Yes, yes.
Yeah, there is like, you know, that there is a traditional or free social network analysis software like that I use in my thesis. It's called Project, and there is another software which is paid. You should pay for this software, and they have a lot of possibilities in the analysis. So in the term of software, there's a lot of software, free software, and other like software for payment, and you can use whatever you want. But in your introduction for question, you said that like strain identifying for virus, and this type of data could be introduced to the software and then linked to the patients. and we can build patient and bond between patient and contacts, and then we can follow each strain through the data. Where is the strain? This strain are going to infect a contact, and then going to other contact, and then so this type of following is also easy. It's not difficult.
Thank you, Dr. Hamdi.
Thank you, Dr. Thank you, Dr. Hamdi. Thank you, Dr. Abdullah. What about Dr. Kamal? Dr. Kamal from India. Kamal Krishna. I think he is not around. Okay, thank you so much, all of you. Inshallah, tomorrow at the same time with Dr. Barfin Fatima from China. She will talk about biohydrogen production, science into thermophilic bacteria. Tomorrow at the same time, inshallah. Thank you so much, all of you. I think there is some certificates Dr. Naif will spread to the emails. If there is any more question, you can email us to our email. Thank you so much, all of you. Dr. Adil? Dr. Adil? Okay.
Yeah,
okay. Please all.
Yeah.
Okay,
Yeah.
please all don't forget to register.
You send the link or what?
Yeah, already shared the link. So far, just 85. But
now,
if you have any problem, okay, just a minute. If you have any problem regarding the link, please just write your name and email.
So, okay, Doctor?
Yes, okay. You can go on.
Thank you so much.
Thank you, Dr. Hamdi, for your sharing.
Thank you so much
for all participants. Thank you, Prof.
Special thanks, Dr. Hamdi.
for
Thank you,
your
Dr. Hamdi.
discussion. Sorry.
Dr. Abdullah Al-Mahdi, inshallah, next month will be with us.
I am with you always. I told Dr. Adil about it.
Yeah,
Anytime you want, I am ready.
This time we prefer to get more network from out of Malaysia. Then next month we are going to focus mainly on Malaysia, inshallah.
You're most welcome.
Okay.
Thank you very much for all this activity.
Inshallah, thank you so much.
Okay.
Thank you. Nice day.
Nice.
Thank you, Dr. Hamdi.
Thank you, Dr. Hamdi. Thank you so much
Thank you, Muhanna. Dr.
for
Muhanna.
your time, for your presentation.
I would like to advocate for new ideas anytime.
Inshallah, just keep with us. So we will see new lot of things.
I think
Thank you so much.
this is microbiology networking.
Yeah.
Like what Dr.
We
Hamdi
built a
said.
network now.
Thank you for Dr. Adil and Dr. Muhammad for that.
Yeah.
Thank you so much. Also, all of you, inshallah, with us, Dr. Abdullah, you are our prof. Dr. Hamdi also.
You're most welcome.
Yeah, you know, Dr. Hamdi is Dr. Hamdi, the أطباء اليمن. He was very nice action. He make a lot of things for أطباء اليمن.
Thanks so
That's
much.
great. That's great news. That's good.
And also, he is the head of our research group.
Ah, great.
We just try to make a difference in research group. You know, we are now all in the diaspora. So if we connect together, we can make something for us and for our country. So
That's right. That's right. Thanks a lot.
Yeah.
Thank you so much. Okay,
Thanks
see
so
you,
much.
inshallah, tomorrow,
Thanks.
9 o'clock.
Okay.
Okay, assalamu alaikum wa rahmatullahi wa barakatuh.
Assalamu alaikum.
Finish, Dr. Naif.
Yes, already copy. Okay. I think everything is okay. Yes. Everything okay.
Thank you, Dr. Naif. Thank you so much.
Okay, you're welcome.
جزاك الله خير.
You too, inshallah.
يلا إن شاء الله نتواصل بكرة على خير.
Okay.
يلا السلام عليكم.
Okay, salam. Do I have to make for all end for all, right? End meeting for all.
I think just wait 5 minutes.
Okay.
Okay.